Inverse trigonometric functions. If you notice on this first sheet here, let me get my pen working right quick. On this first sheet here, we have the unit circle. This is something you should already know by now. If you're still having issues remembering parts of it, it's good to have this handy. This chart here shows the inverse functions for sines, cosine, and tangent. Here's some identities for the inverses of cosecant, secant, cotangent. So this be handy. The inverse sine function. Here is a diagram of a sine function, and then here's its inverse. Okay. Then here is the cosine function, and here is its inverse. The tangent inverse function, and then here's its inverse. Or excuse me, this is the tangent function. And then here's its inverse. All right. So this next set of graphs here shows functions, galleries, inverse trigonometric functions. It shows you the domain and the range of these. And the reason why you notice there's a bracket here on this, on each end, is because it doesn't have arrows at the end of these. It has solid closed circles saying that it stops at this point. However, if you notice this has a triangle on the end, and you notice this has a parentheses, that means that it's continuously going on. However, to take a side note, if it's an infinity, you will not ever have a bracket because you can't stop infinity. If you notice this negative pi halves as a parentheses, it's because the arrow on the end of the line is saying that it's continuously going this function. It's not a straight line, but you know. Okay. So these are good things to have with you as you're learning this section. Example 1 said, we're going to find the exact value of the radians of the expression, the sine inverse of 0. All right. We'll first look at the angle of sine alpha of 0. And we know that it has an interval of negative pi halves to pi halves, which makes sense, right? If you look at your unit circle, sine falls on the y-axis, right? So whenever I look for this here, I can solve for its inverse. And I like to just do a little note on the inverse. There's more than one way to look at it, but if we was to look at a log base b of x is equal to y, and we was to write it in its inverse or in exponential form, we're going to take our base and raise it to the y is equal to the x. So this is what happens when we are wanting to solve for this. This is just an example. This is not, there's another way to look at this. But using that knowledge, we know that we can say, okay, to find its inverse of this function, I need the alpha to come out front. And in order for that to happen, we have to take the inverse of the sine. So now that when I do that, I know that I know sine of 0 is 0. I know its inverse is going to be 0. So my answer is 0. Example 2 says find the exact values in radians in the expression arc sine. That means that we're going to take its inverse. So if I do that, I got the sine inverse of negative square root of 3 halves. And I'm going to go the unit circle, and I'm going to keep this negative because it's an odd. This is odd. And I notice that it falls on pi thirds. Okay, and negative just means it went around another way. Because it always goes around this way. The negative just says we're going around that way. Or the quadrant it falls in, also, there's another reason. It depends on the quadrant it falls in, because that sine is negative here and here. So it could have fell in one of those quadrants. So just go back to the unit circle and look. Find the exact value in degrees of the expression of cosine inverse of that. Well, if we're looking for the cosine inverse, I just want to make a little side note that we know that the cosine alpha of the square root of 2 halves has an interval of 0 degrees to 180 degrees. That is true because it falls on the x-axis, cosine does. So that's why this interval is true. But anyways, let's get back to this. We're going to take the inverse of this. Well, cosine at square root of 2/2 is going to be pi/4, and you write it in degrees, it's 45 degrees. Example 4 says find the exact value in radians of the expression arc cosine. So we're looking for the cosine inverse. All right. So when we do that, now we are going to go find it on the unit circle, and we find that it lands at 5π6. Okay, and cosine is even. And so 5π6 would be right. Find the exact value in radians of the expression cotangent, or inverse of the square root of 3/2. So we know that cotangent, we know, let me get my pencil to work. All right, so let's erase this record. All right, so we know cotangent. Sorry guys, my computer has been silly today. Seems to be a new thing this year. All right, so we're going to find the exact value in radians of the expression cotangent inverse. So let's write that down. Of square root 3/3. I know that the interval for cotangent is going to be 0 to pi. All right, and then I can rewrite cotangent as cotangent alpha of 1 over tangent, which we know is cosine alpha over sine alpha. And that's why we get the interval we get, because if we base the interval in the denominator, it can cause it to be undefined, so we have to be careful. So we're going to look at the denominator of this here, of this unit circle, and we notice that it falls from 0 to pi/2. Okay, so knowing that, let's go a little further. Now we're going to go up there and grab the identities of cotangent. And this is the identity we get based upon the information given. And now I can plug in what I know. Well, we know x is going to be square root of 3/3. I'm going to plug it in. And then we're going to calculate it out. And what do we get? We get pi/3. And if you need to check your, type in your calculator, the tangent inverse, square root of 3/3. And that gives us, and I just skip this part, and I want to plug it in right quick. We get this. All right. So we get pi/2 minus pi/6. And in order to subtract these, we have to have a common denominator, and the denominator is 6. I'm going to multiply top and bottom by 3 on this fraction. So now I got 3 pi minus pi over 6, which is now 2 pi over 6, which reduces down to pi/3, and this is where the answer came from. Okay, so let's do example 6. Example says we got arc cosecant, so that means we're going to take the inverse of cosecant. We're going to use its identity, and we're going to plug in what is given to us. Oops, don't forget it's a 13, not a 3. So we're going to plug that in. And when I type it in my calculator, I'm going to round to the nearest hundredths. And this is my answer. Okay. Number 7 says find the exact value of the expression tangent arc sine. So I'm going to take the inverse. So we need to do the inside first before we take the tangent of it. Okay, doing that, I know that I have sine inverse of negative square root of 3/2. And we know when we plug that in, we're going to get a negative 60 degrees. Okay, now we're going to find the tangent of that. And when I tap that in, I get a negative square root of 3. Number 8 says find the exact value of the composition without using a calculator. So I'm going to take my cosine. This is taking the cosine inverse of the cosine. So we're going to take the inside first, and let's find it. Cosine of a negative 5 pi thirds, we find on the unit circle as a half. And then we're going to plug it into the arc cosine of a half, and it gives me pi thirds. Remember that cosine is an even, so when we pulled the negative out, we got a positive, okay? All right. So now, get this page to scroll. Whoops. Let's do our last one. Come on. There we go. In a circle with a radius r, we have a central angle theta, intercepts a chord of length c, so we're going to call c chord, where theta is equal to this formula right here. Okay, we have an airplane at 2,184 feet flies directly over a gun that has a range of 2,275 feet. What is the measure in degrees of the angle which the airplane is within range of the gun? All right, so what we're going to do is I want to use the Pythagorean theorem, the a squared plus b squared equals c squared, because we know that we got this triangle going on. But when I do that, what I want to do is relabel. I'm going to say, okay, A is going to represent the height. Okay, height of my, right here, this is my height, my H. I'm going to let C represent the chord. Okay, we don't know what the chord is. And then I'm going to let the range be R. So I just rewrote it. Now you can use whatever notation you want. Just know that in the textbook, it may have this notation. All right, so now I'm just going to plug in what I know. I got 2,184 feet squared plus the c squared equals the 2,275 squared. And I'm going to get c by itself, so I'll have to subtract the 2,184 squared. I'm not going to square nothing right now because it's just going to give me a really long number, and I don't want to miss a number out in there. Now that I got it written like this, I can go, okay, so now let's go ahead and square each part. Now, if you want to type it all in or do it on paper with your, and calculate it all in once, that's good too. It will more than likely keep you from making a typo mistake, because sometimes we can write something down and just leave a number off, or see a number and write it twice or whatever. So just be careful. Okay, so now I need to know what C is. So what I'm going to do is I notice this is C squared, so I got to take the square root of both sides. And usually when you take square root, it's a plus or minus because it's an even root. However, in this case, we're not going to worry about the negative, right? Because we're talking about length. Well, when I do that, I get C is equal to 637. All right, we're almost done. Now that I know what C is, let's see if I can get my paper to scroll. Sorry about this, guys. Don't know what to do. All right, let's do this again. All right, so I'm going to use this part of the paper. So now that I got C is equal to 637, I know that I got this range that I'm talking about. So I'm going to add it to it again, and I get 1274. Now that I got that, what I'm going to do is take the formula from above. Oops. Now it's going to act up. Sorry guys, trying to fix my computer here. So now we're going to take the formula from above and plug in what we know. So we know what C is. It's 1274 squared. And then we're going to square it because that's what the formula says. We know 2 times R. Well, R was 2275, and we're going to square it. And then we'll type that in a calculator, and we get 0.8432. And then I'm going to go approximately because we're going to round to the nearest tenths. And this is my angle. That's the angle of the airplane that's within range of the gun. Thank you.